In this video, we have to take some questions on how to compute the ARIMA model. The ARIMA means the auto-regressive integrated moving average. So, for more on this topic, you need to subscribe to this channel. Question: compute ARIMA 3, 2, 3 model. What this simply means is that the auto-regressive part is of order 3, the differencing part is of order 2, and the moving average part is of order 3. Now, we now write the auto-regressive part of order 3 to give us the auto-regressive part of order 3 will give us 1 minus phi 1b 1 minus phi 2 b2 minus phi 3 b3. So this of order 3. The differencing part we have 2 here. It will have the 1 minus b raised to the power of 2. And the moving average part is of order 3 again. Now the moving average part is of order 3, which is 1 plus theta 1b 1 plus theta 2 b2 plus theta 3 b3. Now we should recall what we have as our model for the ARIMA. Yes, you should note that our ARIMA model is 5p v, our differencing st to be equal to theta 2b dt. So this is how our model is. So whatever we've gotten here, we'll now put it the way our model is. That is what we do. For more on this topic, you need to subscribe to this channel. Now, for me to do that, for me to write whatever we've gotten here as this, we move over to this side of the board to do it. So move over to this side. We have the ARIMA part, which is this part, our auto-regressive part, which is this part. We write it as first to give us 1 minus phi 1b 1 minus phi 2 b2 minus phi 3 b3. We have our differencing part to be 1 minus b raised to the power of 2. So we have 1 minus b raised to the power of 2. Here we have our st. Our st will be equal to, we have our moving average part, which is the whole of this, which is 1 plus theta 1b plus theta 2b squared plus theta 3 b raised to the power of 3, then et. Yes, this is what we have. Now, this is our model, and this model is looking like what we have here. But we can rewrite this out properly so that we'll be with the time series values only. Now, we should recall that we say note that 1 minus b squared xt is equal to, if we open this from quadratic equation, you can get 1 minus 2b plus b squared, then xt. Now, if we multiply this xt by this, we get xt minus 2 bxt plus b squared xt, which is the same thing as xt minus 2 xp minus 1 because of the backward shift plus xp minus 2 because of the backward shift before it. Now, the whole of this, we can take it to be xp double prime. So the whole of this we have is this. So we can write what we have here. We can write it as 1 minus phi 1b minus phi 2 b2 minus phi 3 b3 xt double prime. So that's what we have here. Xt double prime to be equal to 1 plus theta 1 b plus theta 2 b squared plus theta 3 b raised to the power of 3 et. This is what we have. Now we can open this bracket. We can open this bracket. If we multiply this with whatever that is inside the bracket, we have this multiplied by this, we have x t minus this multiplied by this, we have 5 because of the backward shift, we have x t minus 1 minus phi 2 x t minus 2 minus phi 3 x t minus 3 to be equal to et. This multiplied by this, we have plus theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3. So this is what we have. Now, with this, we can now write the model itself. With this, we can write the model itself. For more on this topic, you need to subscribe to this channel. Now, we can write this our model to be ft to be equal to the whole of this can move over to this other side of the board to give us this phi 1 xt minus 1 plus phi 2 xt minus 2 plus phi 3 xt minus 3 plus theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3 plus et. So this is what we have. This will not be the model we have written here. This is simply how we can compute ARIMA 323 model. Very simple. So for more on this topic, you need to subscribe to this channel. So with this, we take yet another question on ARIMA modeling. This is how we can simply compute the ARIMA model. So for me to do that, we have to delete or clean this part of the board. For me to take yet another question. So for more on this topic, you need to subscribe to this channel. For more on this topic, you need to subscribe to this channel. So we have here another question. Complete ARIMA 3, 2, 4 model. For this ARIMA 3, 2, 4 model, our auto-regressive part is of order 3, our moving average part is of order 4, while the differential part is just 2. Now, the first thing to do is to write the auto-regressive part of order 3. Auto-regressive of order 3. Auto-regressive part of order 3 will give us 1 minus phi 1, the backward shift 1 minus phi 2, the backward shift 2 minus phi 3, the backward shift 3. Also, the differential part is of order 2. We have differential of order 2, which is 1 minus b raised to the power of 2. Now, the moving average part is of order 4. The moving average part is of order 4. So we have m a moving average of order 4 will give us 1 plus theta 1 b plus theta 2 b2 plus theta 3 backward shift 3 plus theta 4 backward shift 4. So this is what we have. This is what we have. Now, the next thing to do, we say we recall for what we have as our model. Our ARIMA model says that we have 5p b, our differential of order d, xt to be equal to theta of order q et. So these are ARIMA models. This is exactly our ARIMA model. So whatever we have here, we will write it in this form. Whatever we have here, we will write it in this form. When we write it in this form, it means we have found the model for ARIMA 324 computation. So the first on our list is the ARO part. That means this part. This part is what we first write. We write it this side. The ARO part is 1 minus phi 1 b minus phi 2 b2 minus phi 3 b3. Then multiply by the differential part. Our differential part is 1 minus b raised to the power of 2. We also have our xt part, which is the time change xt, which is equal to, now we have the MA part, the moving average part, which is of order 4. So we write it as, which is 1 plus theta 1b plus theta 2b squared raised to the power of 2. Or we put it here, we say plus theta 2 b raised to the power of 2 plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that's what we have. That's what we have. That is simply our model. That is simply our model. If we can compare it with what we have here. Now, but we can still write this out properly. So it will be very easy for you to. So we say no. We have to know that 1 minus b all squared xt is equal to, from quadratic equation, we can expand this to give us 1 minus 2b plus b squared, then multiply by xt, multiply by xt. We can use this xt to multiply the whole of this to give us xt minus 2bxt, this multiply by this plus b squared, that means the backward shift xt. We have already talked about how we can compute the backward shift in our previous lesson. Now we have this to be equal to xt minus 2. Because of the backward shift, we write it as xt minus 1 plus, because of the backward shift raised to the power of 2, we have xt minus 2. And this is the same thing as equal to xt. We can say, let's take it as this xt double prime. So we have this to be xt double prime t. So that means we can rewrite whatever we have here back. So wherever we see this, we put this. Whenever we see the one of this, we put this. So that means that our model will now be 1 minus phi 1b minus phi 2b minus phi 3b 3, then x t prime prime to be equal to, because the whole of this is this, to be equal to 1 plus theta 1b plus theta 2b squared plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that is it. The next thing we do is to expand whatever we have here. We open the brackets. Then this, okay, this is ET. We put our ET here, and this, we also put our ET here. Sorry. We put our ET because we have the ET in our model. So that is it. This is our model. This is our model for ARIMA 324. We are only trying to expand this to open it. For me to do that, we have to use the backward sheets and the pressing part to be equal to this. Since this is equal to this, so wherever we see the whole of this, we put xt double prime. So we expand that. For me to do that, we move over to this side of the board to do that. So we can open this. If you open it, we have xt prime prime. That means if we multiply this by this, we have xt prime prime minus phi 1 x t t minus 1 minus phi 2 x t minus 2 prime prime minus phi 3 x t minus 3 prime prime to be equal to, now if we multiply et by this, we have first et plus, if you multiply et by the second one here, that means theta 1b, we have theta 1 et minus 1 plus theta t et minus 2 for the second one plus theta 3 et minus 3 for the third one plus theta 4 et minus 4 for the fourth one because we have a moving average start of order 4. Now, it then means that we can make this the subject of formula. We can make this the subject of formula to write it as st to be equal to, now this st prime prime to be equal to this. If you move the whole of this part to this other side of the equation, you have it as positive. So it will be phi 1 xt double prime plus phi 2 xt prime prime minus 2 plus phi 3 st minus 3 prime prime plus, we start with this. We can start with this. Theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3 plus theta 4 et minus 4 plus et plus our error 10 or the white noise. So this becomes the model for the given ARIMA 324. This becomes the model for the given ARIMA 324. Or we can still write it as this, but expanding it, we write it as this. So for more on this topic, you need to subscribe to this channel to get more questions and more teachings on ARIMA model. The SARIMA models are models that are used for forecasting in time series. What are SARIMA models? SARIMA means seasonal auto-regressive integrated moving average model. So that's the meaning of SARIMA. Unlike ARIMA, you just add the seasonal part of it to make it SARIMA. So this SARIMA is written as P, D, Q, small letters, then P, D, Q, capital letters with the seasonality. Now, the next thing to do is to first write out the model, then define each parameter so that you know how to use it to compute the SARIMA model. Now, the first thing to do is to write out the model. The model for SARIMA is written as 5B P, 5, this is the seasonal part, PS, B, P multiplied by S. Then we have the differencing part. We also have the seasonal part, the differencing part with seasonality. We have the non-seasonal part, the differencing part that is the non-seasonal part. Then we have XP. We also have the moving average part, which is Q, B, Q. Then theta Q comma S, B, Q multiplied by S, then ET. ET. So this is simply the SARIMA model. This is how it is written. So whenever a question is given like this, that question will appear in this form. When it appears on this form, then you know you have completed the SARIMA model. Now, we define each of these parameters. Phi is here. For more on this topic, you need to subscribe to this channel. Here phi p BP is the autoregressive parameter. Of course, this one is the one that has non-seasonality, or you say it's the non-seasonal part. We also have find that has the seasonal part, P multiplied by S is the autoregressive parameter with seasonal part. We also have this with the pricing. This is called the differential seasonal part. Now, we also have this. It's also differential, but the non-seasonal part. So, we have this. We also define what they are to show you how it is being used. Differential non-seasonal part. We have XT. This XT is the time series. Okay, we say time series value. You can call it the time series values. We call it the time series values. Now, we have the moving average part, which is this. So we have theta. For more information or for more on this topic, you need to subscribe to this channel. So we have the moving average part. So this is the moving average parameter, non-seasonal. Non-seasonal part. Then we also have the moving multiplied by S. We also have the seasonal part for the moving average parameter. So is the moving average parameter seasonal part. Then we have ET. ET is the error term. Error term, or better still, you can call it the white noise process. Then we have S. This S. This S means seasonality. So it is seasonality of the model. So we have succeeded in defining all of these parameters. And I will also show you how they are being used. How they are being used when computing. How they are being used when computing. So for you to do that, we have to delete this part of the board to now show you how they are being used. So for more on this topic, you need to subscribe to this channel. So since we have this, we take it gradually. We have to delete this part of the board. For more on this topic, you need to subscribe to this channel. So we'll show how they are being used. Now, the 5p BP can be computed as 1 minus phi 1 B1 minus phi 2 B2. It continues that way to give you 5p BP. So this is how this part is being computed. Now, the seasonal part of it is computed as phi p comma s b p multiplied by s is computed as 1 minus phi 1 s b 1 multiplied by s minus phi 2 comma s b 2 multiplied by s, which is 2s. It goes that way to give us phi p comma s b p multiplied by s. So this is how the seasonal part can be computed. This is how the seasonal part can be computed. Now, we have the differential part, which we already stated here. So the differential part, which is this, can be computed as 1 minus d, then d multiplied by s. That is ds. So this is how this part can be computed. Now, we also have the non-seasonal part for the differential. The non-seasonal part for the differential can be computed as 1 minus d raised to the power of d. We have the moving average. The moving average part. How is it computed? The moving average part, we have theta q d q to be equal to 1 plus theta 1 b plus theta 2 b2 plus, it continues that way, theta q dq. Theta q bit q. So that is how it can be computed. We also have the seasonal part of it. The seasonal part of it. The seasonal part of it, that is theta q s, then b q multiplied by s to be equal to 1 plus theta 1s, 1 comma s, b 1 multiplied by s plus theta 2 comma s, b 2 multiplied by s plus, it continues that way, plus theta q comma s, then b q multiplied by s. So that is how it is being computed. That is how that part is being computed. So this is how we can use the SARIMA model. This is how the SARIMA model can be computed. For more on this topic, you need to subscribe to this channel. So with this, we can take just one question to see how we better understand what we are saying. We can take one question to add to this. We can take one question. So for me to do that, we'll delete this part of the board. For more on this topic, you need to subscribe to this channel. So we can start with this question. Compute SARIMA one 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 with seasonality 2. So we can compute this. How do we compute this? From what we have explained before now, we can compute this. We also delete this part of the board. For more on this topic, please subscribe to this channel. Now we can compute this. The first thing to do is to write the model, the SARIMA model, and the model is given as 5P BP 5P comma S B P comma S. We have our differencing part with seasonality. We have our differencing part. We have X2. We have the moving average part. Then we have ET. So whatever we are doing, we complete it to this form. Now, the first part, which is 5 BPP, this is PDQ. PDQ, that is P, D, and Q. Then capital letter P, capital letter D, and capital letter Q. Now, for the auto-regressive part, we have it of order P, which is 1, just 1. So we have 1 minus phi 1, phi 1, D1. That is it. For the differencing parts, okay, we have here, for the seasonal part of it, we have phi, the seasonal part, B, PS, the equals. For the seasonal part, we have the seasonal part, we have it as 1. So we have 1 minus phi 1. We have our seasonality to the 2. 1 comma 2B, just 1. So we have 1 multiplied by S, that means 1 multiplied by 2, which is 1 multiplied by 2, which is 1 minus 5, 1 comma 2, then B squared. Also, we have our differencing, the one with seasonality, which is 1 minus D, then D multiplied by S, which is 1 minus D. We have D to be 1. The order is 1. multiplied by s, which is 2. So we have it as 1 multiplied by 2, which is 1 minus b raised to the power of 2. We also have our difference in here. Our difference in with non-similarity. That means this part, which is 1 minus b raised to the power of b, which is 1 minus b raised to the power of b. B is 1, just 1. The non-similar part is 1. So it doesn't mean that we have just 1 minus b. Then we have xt, which is our time series value. We now have the moving average part. The moving average part, which is q, the one with non-seasonality, is equal to, we have it as 1, because we have all of them here as 1. So the moving average part, which is q, is this. We have it as 1. So it will now be 1 plus just 5, 1 multiplied by s, 1 comma s, that means 1 comma 2, then b raised to the power of, we now have 1 multiplied by 2. 2 is equality, so we have 2 here. That is 1 multiplied by 2, 1 multiplied by 2. So we can write it to be 1 plus theta 1 comma 2 b raised to the power of 2. We also have the moving average with seasonality. So we have theta qs b q multiplied by s, which is equal to 1 plus, sorry, this part is the part with non-seasonality. So the part with non-seasonality is just theta 1b, which is equal to 1 plus theta 1b, b raised to the power of 1. Now the one with seasonality is theta 1 comma s is 2. S is 2, which is our seasonality. Now we have b 1 multiplied by s, which is 2, which is the same thing as 1 plus theta 1 comma 2 b squared. So the next thing to do is to now write out our SARIMA model. How do we write out our SARIMA model? We will write our model to be in this form. We write the model to be in this form. Now, the first part we have is this. The second part, the third part, the fourth part. That means the auto-regressive part with non-seasonality is 1 minus b. So we're writing our model, writing our model, we have 1 minus 5 1b. That is for the auto-regressive non-seasonal part. Then the auto-regressive seasonal part is this. So we have 1 minus 5, 1 comma 2 b squared. Now we also have our differencing, the seasonal part. We have it as 1 minus d squared, 1 as 1 minus d squared. We also have our differentiating part, non-seasonal. That means this part. We have it as just 1 minus b. Then we put our xt. We put our xt, which I have done there. Now we move over to our moving average part. Our moving average part will now be equal to, the first part here will be our moving average part. We got 1 plus, we have this as equal to plus theta 1b multiplied by this. So we have 1 plus theta 1 comma 2, then b raised to the power of 2. Then we also put our et. We put our et. So if you have to compute SARIMA, this is simply how to compute the SARIMA model for a given time series. Like we said initially, that the SARIMA model is used for forecasting. Once we go through all these processes, then we'll be able to compute any equation that is given to us on SARIMA model. So for more on this topic, you need to subscribe to this channel. So we'll be taking some questions. First on our list is question 1. So you can say compute SARIMA. You can say compute SARIMA, sorry, 0, 1, 0, and 1, 0, 0 with seasonality of 4. So we can be asked to compute that. Well, it's quite easy to say solution. For more on this topic, you need to subscribe to this channel. Now, we'll take from the simpler part to the more complex one. We can recall, that our simpler model can be written as pi p d p pi p s d ps. We have our differencing part, do the seasonal part. We have the non-seasonal part. We have xt to be equal to our moving average part, then et. This is the model. Now, our autoregressive, of course, this is P, this is PDQ, and the seasonal part PDQ. Now, for the autoregressive part, the non-seasonal part, we have 0, which is nothing. For the differencing, our differencing, we have pi b to be equal to 1 minus b raised to the power of b, which is equal to 1 minus b. We have b to be 1. Also, for the seasonal part, we have this. For the seasonal part, that means pi p then s b p. This s is 4, while our p is 1. P s to be equal to 1 minus pi. This is ps. Our p is 1, comma s is 4. Then b, we have ps here. Our p is 1 multiplied by 4. That is all we get. So we can write it as 1 minus pi 1 comma 4. Then b 1 multiplied by 4 is 4. Of course, the differential part is 0. And the moving average part for our seasonality is also 0. So we don't have anything here. So it will now be remaining our et. So we can write this out from the model. From the model, We can write our SARIMA model to be, 1 minus pi 1 4 b 4 for this part. Now, see this part is 0, this part is nothing, this is 0 too. Now we have this part, which is this, which is equal to 1 minus b. Then we'll write out our xt equal to, of course, our moving average, we don't have anything for it. Our moving average part, which is this, is 0. That means the non-seasonality, the one with the non-seasonality, the one with seasonality is also 0. So we have what is remaining is ET. So this becomes our model for the given question. This becomes our model for the given question. For more on this topic, you need to subscribe to this channel. We'll also take another question so that we better understand how to compute the SARIMA model. Now, the next on our list will be question 2. Compute SARIMA 2, 2, 3, 1, 1, 1 with seasonality 3. With seasonality 3. So, like we have said, solution. For more on this topic, you need to subscribe to this channel. The first thing to write out will be to write out the model. So we can write our model to be file 2 BP for the non-seasonal part, then file P S B P multiplied by S. Then we have the seasonal part. We also have the non-seasonal part. We have XP to be equal to theta non-seasonal part B and theta seasonal part D is a bar of Q multiplied by S, then ET. So this is our model, the SARIMA model. The first thing to do is to compute the auto-regressive part. So we compute this part first. And here, of course, we know that this is our P, this is our D, and this is our Q. This is our P for the seasonal part, this is our D, and this is our Q. This is the seasonality, which is 3. Now, we write this part out. This part, file P, B, P, will be equal to 1. We have it as 2. We have it as 2. It will be 1 minus pi 1 B1 minus pi 2 B2. So that is all we have. Now, we also write our differentiating part. Our differentiating part will now be, okay, the next on our list is the seasonal part. The seasonal part of our auto-regressive is 1. We have P to be 1, the seasonality part. So our seasonality part will be pi P, comma S, then B, P, S to be equal to 1 minus pi 1, comma S is 3, B, S, S is 3, minus, okay. So this is 1 minus pi 1, which is P, 3. 3 is the seasonality. P, comma S, 1, comma 3. Then B raised to the power of the first one will not be PS. So the first one we have here to be just 3. will be 3 multiplied by 1. That means 1 multiplied by 3. So we have this. The next on our list is the seasonal part, the differencing part, the seasonal part. We have it as 1. So the D here is 1, the S here is 3. How do we complete this? We'll move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. So I'll be deleting this part of the board so I will continue from where we start there. Now, we have our seasonal parts to be our differential part ds, which is 1 minus b, to give us our d here is 1, the d here is 1. Also, our s here is 3. So it is written as 1 minus b multiplied by s, which is 1 minus b 1 multiplied by 3, which is 1 minus b raised to the power of 3. Now, we have our non-seasonal parts. The non-seasonal part is to give us the non-seasonal part is 2. So this is the same thing as 1 minus b raised to the power of b, which is 1 minus b raised to the power of 2. So this is what we have. Now, we also have our xt. We also have that of the moving average. The moving average is 2. The moving average is 2, so we have theta q then b raised to the power of q is equal to 1 plus theta 1 b plus b1 theta 2 b2. That's for that. Also, we have the moving average, the seasonal part. The moving average, the seasonal part, we have it to be theta q comma s b q s multiplied by s to be equal to 1 plus theta 1 s is 3, 1 comma 3 b 1 multiplied by 3 plus we have it to be we have the moving average part, the seasonal moving average part, which is this, just 1. So we have it to be 1 plus theta 1 comma 3 b raised to the power of 3. So we have finished computing what we have here, SARIMA 222111. This is it. All we need to do is to now put it in this form. We now put it in this form. Once we put it in that form, we have succeeded in writing our SARIMA model. And for you to do that, we do it on top. So we put it in the form here. We write it as for more on this topic, you need to subscribe to this channel. Now, we have this part, we have this part. So we write 1 phi 1b minus phi q b squared 1 minus phi 1 3 b raised to the power 3. We have our differential part, the signal to be 1 minus b raised to the power of 3 to be equal to, now, okay, we still have this, the signal part. The non-signal part is 1 minus b squared to be equal to the moving average part. Now we are writing the moving average part is this and this. The moving average part will now be the first moving average part is 2, and the second moving average part, the seasonal part, is just 1. It's 1. So we have it to be 1 plus theta b plus theta 2 b squared and 1 plus theta 1 3 b 3 then e2. So this becomes our model. This becomes our model. This becomes our model for SARIMA 222111. So this is simply how to compute the SARIMA model. In case you are asked to compute the SARIMA model, given any question or any parameter, you'll be able to compute that. For more on this topic, you need to subscribe to this channel.